Okay, on number 1 it says tell whether the graph of each relation is the graph of a function. If it is, give the domain and range of the function. This is going way back in time. How can we tell if a graph is a function or not?
If it is a function.
Ready?
Yep.
It's called the vertical line test. If you can draw a vertical line any place on the graph and it only hits once, then it passes. This would be yes, it is a function. But if you draw a vertical line and it's twice anywhere on the graph, then it is no, not a function. Definition of function is each x value only has one y value that it's mapped to. So on a graph, it's the vertical line test.
So is number 1 just yes?
Number 1 is yes, but then we gotta state the domain and range.
Domain is how low it goes, right?
No.
No, domain is how far it goes. And range is how from base to height.
Domain are the x values, so how far does it go left to right? And then range is the y value, so how much it goes down and up. So number 1, the first part is yes, it is a function. And the second part, domain. So there's a continuous set of points from the left to the right. Continuous set of x values going left to right. What is the smallest x value?
-2.
-2. Okay, what's the biggest x value?
6. 1, 2, 3, 4, 5.
5. So all the x values between -2 and 5 are included. So how do we show that?
Greater than -2, less than 5.
Greater than or equal to, and less than or equal to 5. Because 2 and 5 are
And
negative.
that's the answer? Or no?
That's the domain. I probably should have put d equals that stuff. And then the range is kind of a similar idea. It's the y values, so down to up. So there's a continuous set of points from, what's the bottom? How low does it go?
-1.
-1 down. And then how high does it go? 2. So that's the range.
Okay.
Okay. Easy peasy, right?
Yes, sir.
Number 3.
It passes the vertical line test.
It passes the vertical line test. So it is a yes. And what is the domain?
0.
Isn't it just y equals x?
6. 0 and 6.
No.
What? 1, 2,
No.
3, 4, 5, 6. 6.
Okay. There are not a continuous set of points on this one. There's only a few points.
So would it be equals 0 equals 2, 1 equals
0, 2, 4, 6.
Oh.
There's only like 4 points. So only those 4 x values of each point. 0, 2, 4, 6. Does that make sense?
Yeah.
Okay, and then the same thing on the range.
0, 1, 2. Wait, 1, 4.
1, 2, 3.
0, 1, 2, 3.
Is a no-go on the line test.
Yeah, 5 fails the vertical line test. It's not a function, so it's a no.
It doesn't have a domain and range, does it?
It does have a domain and range.
But we don't have to give it because it says if it is, give the domain range.
Oh, you're right.
Oh, I guess. Good job,
It does say that.
Really clutching up there.
Clutching up.
Only if you agree.
You're like a bump on a pickle, Jackson. In the good sense.
That's not how the expression is.
Really? You know how it's used?
Well, I assumed it means you're useless. Because
Like
you
a
have
bump.
context. It's
Like a bump on a log. Yeah.
It's like you're not doing anything. I'm clutching up, so I'm not.
He's not no bump on a pickle. Yes.
I'm clutching up, so I'm not a bump on a pickle.
Anybody in the world heard that sentence, they would be thoroughly
So
confused.
What school do you go to?
He's having a seizure, don't worry about it.
Just think, someone randomly comes across your videos and just hears this on YouTube, and they're so confused.
Yeah.
You know,
Yeah, I'm not sure I recorded the beginning of this conversation, so it's probably very
There's
confusing.
no way to get.
I figured out how to fix my sleeping problem. I just started watching a
Drugs?
YouTube channel.
There you go.
Put me right to bed.
Did you really try?
Oh, no, I didn't.
I just watched the Indian guys build.
Oh, the
houses.
build houses guys, yeah.
I found one guy who just lives out there. That's what he does.
Oh, he actually.
He casually has $2,000 worth of a camera equipment, and then he just does that.
Just nothing.
Yep.
Okay, 7, 8, I'm not a big fan. 7, I kind of mentioned this in passing the other day. We did maybe one assignment on this last year. Do you guys know what shape this makes if you graphed it?
Parabola, because that's the only shape I know.
No, y equals x squared is parabola. X squared plus y squared equals something. Anybody?
A line.
It would be x squared plus y squared makes a circle with the radius of square root of this, radius of 1, so it would be basically that thing. The question is, explain why that does not define y as a function of x. They probably wanted something because it's a circle and it fails the vertical. I don't know what they want to do to write actually.
Because it fails.
You're right, we
vertical
should skip
lines.
that.
It's a circle and it fails the vertical line test. That's fine.
Did you help us on 8?
Yeah, it's. Oof. They probably wanted something like there's 2 y values for most x values or something. Anyway, number 8, yeah. Alright, fine. We'll do it. What shape does that make? Well, if we solve this for y,
Oh, can you
how do I get rid of that?
not square root, but triple root?
Cube root, yes.
Triple root. Wait, does it not get rid of that 3 too?
Oops, I forgot that one.
Does it get rid of that x?
No, when there's a minus there, you have to cube root all of it, or plus. If there was a times, you could do that, but not a minus. You guys probably don't recall this, but you guys remember what shape? This has been a long time ago, in algebra 2. Remember what shape something like that made?
What was it?
Value of x, or square root of x, I mean.
Shoot.
Zigzag.
Kind of like that.
Oh, that's right.
Those were weird.
Yeah. You can't put a negative in because that's imaginary, but starting at 0. So square root of 0 is 0, square root of 1 is 1. But then when you get square root of 4 is 2, it gets goes up slower and slower basically. And on the cube root ones, it's kind of the same, but it actually has you can put negatives in and it works. So it's more like this. Looks about like that. Anyway, it's the answer is each x value has its own one y value. So that's why it's a function. Each x value has one y value.
That was 8.
Yeah. the book wrote, there's only one y value for each x value. Yeah, so pretty much the same thing as what I said. All right, number 9. This is, we probably did a little bit of this last year too, only in one lesson, but it says write the domain.
Oh no, it's A, B, and C.
Oh no. So normally on a function, like if I just said y equals x, it's like, we graphed that yesterday, remember, like number 1. The domain, what is the domain on this?
Infinite.
Yeah, unlimited, all real numbers. By the way, I think the graph on number 6 has an infinite domain too. So the domain is all real. It goes forever, left and right, and that's normal. That's like a normal function does that. But sometimes there are limiters. If there's a variable in the denominator, what cannot go in the denominator?
Negative.
No,
The same number,
no,
0.
0. You can't divide by 0, right? So whatever x value makes the denominator 0 is going to be a no-no. So this, everything you can plug in anything for x into this function except for
0.
x cannot be 0. So it's kind of like all real numbers except for 0, basically is the answer. But you can just put x is not equal to 0. That implies it can be anything else. Okay. And if the denominator looks more like, if there's more to it, you just say what x value would make the denominator 0. In this case, it would be 3, right? So x couldn't be 3. It's kind of like when we solved equations.
So on B is x cannot equal 9.
Yeah, x can't be 9.
But it's still all real numbers, right?
Well, it's everything but that, yeah. But when you put x is not equal to 0, that means it could be anything besides 0. So it's kind of like all real numbers but 0, but you just put x is not equal to 0. Yeah, I guess let's keep going. So on C,
Would it be 2?
Would it be 2 A?
yeah. So there's a couple ways to think about it. Like solve this for x. This is what can't happen. You can't let this equal 0. So remember when you do the square root trick that it's plus or minus square root of 4? In other words, 2. Because negative 2 squared is also positive 4. Minus 4. So on C, it can't be 2 or negative 2. So basically it's not equal to 2 or negative 2.
That wasn't very fun.
Was it not?
Not a fan.
On number 10, it looks like you're going to have to factor on B and C. So good luck with that. Number 11, give the domain, range, and zeros of each function. Do you guys remember what shape absolute value of x took? If you forget, how can we figure it out?
Isn't it vertical line or
No.
horizontal?
No, you're thinking, no. If it was like y equals 2, you go up to the y-axis at 2 and draw a horizontal. If it's like x equals 2, you go to the x-axis at 2 and draw a vertical. This is more like y equals absolute value of x, though. There's a y and an x. It's usually slope, intercept kind of a thing, but if it's an absolute value,
Always gotta be positive.
let's plug some stuff in. Maybe this will remind you. If I plug in negative 2 for x, what comes
2.
out? 2. By the way, these are interchangeable, right?
Yeah.
If I plug in negative 1,
1,
0,
0,
1,
1,
2,
2.
and
Is
if
it just a straight line?
graph
Straight
those.
diagonal line.
-2, 2,
Oh, it's a V.
-1, 1, 0, 0, 1, 1, 2, 2. So normally it's a diagonal if it's just y equals x. We did that on number 1 yesterday. But on this problem, it bounces up. Why does it bounce up? Because all the negative y values turn into positive y values.
And is that a double root or whatever?
No. Oh, yeah, I know what you're talking about. No, that's something else. Okay, what was the question? I forgot. Name the domain. So what would the domain for this be?
Infinity.
All real numbers, yes.
And then the range.
Because you can go
would be
forever left to
anything
right. There's no
above-
limits to what you can plug in right here.
Yeah, and then the range would be greater than or equal to 0. Right?
Yes. So as the lowest point on this graph is at 0. So it's the range is y is greater than or equal to 0.
What's the zeros?
0. Right? Because if you plug
Yeah.
in 0, you get 0.
So the 0 is where the function equals 0 out. It's where it hits the x-axis. So it's at 0. X equals 0 is the 0. Is a different kind of problem.
3 to 12. Please.
Fine. Okay, what on B? What would the -2 do to the graph?
A -2.
Yeah, that's directly on the x.
Take it down 2.
No.
Well, no, it would make it go 2 times slower. No.
It's actually a +2, right?
As a +2?
Well,
It
since
turns
it's in
into a
absolute
plus.
values.
No, no.
Uh,
Okay,
B1.
I'm gonna add something on here. This makes it go up 3. If it's directly on the x, it affects the left-right motion.
Right.
It goes right 2. So this is just right 2. I mean, we could plug stuff in again, but it'd be a little harder to figure out. So it's still a V shape, but it's moves right 2.
So,
Right, does anything change?
Where'd you get
The same as A, but it moved right 2. I just made that up.
so we put the same answer.
So what's the domain?
Domain is all real numbers again. The range is also y is greater than or equal to 0.
What's the zeros of the function?
It
2.
would be -2.
2. Bonk. 2. Okay, on C, what does that -2 do to the graph?
Down
Down 2. So it's gonna look kinda like that. So what's the domain?
All real numbers.
What's the range?
Y is greater than or equal to 2, -2.
Yeah. And what's the zeros of the function?
Uh, 2. Right?
2 to negative
How'd you get that?
because it's absolute value.
It's a perfect, these are perfect diagonals.
Oh.
2 and -2.
Is it okay if we put plus or minus two?
12.
Okay, we kind of talked about 12 earlier. what shape it made?
Does I forget? Oh, the side. Yeah.
It's like a hill. I don't know how to describe it. Yeah. So when you plug in 0, you get 0. So 0, 0. Can't plug in a negative. So this one has a limited domain. So you gotta start at 0. If you plug in square root of 1 is 1, so that's 1, 1. Square root of 4 is 2, so 4, 2. It just, and like the next one that comes out nice is like 9. 9, 3. So it'd be like there, maybe more like. Anyways. Just a flattening slope. Gets harder and harder to get up. The square root kind of hampers. Alright, so.
Does it ever start going down or no?
No, because the bigger the x, you think about it, the bigger the x value you plug in, if you plug in 100, you get 10. You plug in, I don't know, like 400, you get 20. So the bigger the x value you plug into a square root, it still gets bigger,
Yeah.
but it just gets bigger slower and slower.
Okay.
So it still goes up forever though. Anyways, what's the domain? Greater than or equal to 0. The lowest x value is 0.
This is for 12A, right?
Yeah. What's the range?
Greater than or equal to 0.
Yeah, same thing. 0 is as low as it goes, and it goes up forever. And what are the zeros of the function?
I don't know.
0. Alright, guess what the B, B. This one's tricky, darned. So instead of a T, they have a minus T. Guess what that's going to do?
Imaginary.
No.
Upside down.
Yeah, that's a good guess, but it's not quite. This one's tricky.
Inversion. It doesn't.
Okay, if it had said this, that would be upside down. But when you put it directly on the T, like this, it actually flips it horizontally. Like what was a positive x value, like over here, becomes a negative x value, so it flips this direction. So it's more like that. Because if I plug in a positive 1 to the T, this would be a negative 1, which would make it imaginary. So there is nothing over here. But if I plug in a negative 1, then I actually get square root of positive 1, which is 1. If I plug in a negative 4, I get square root of positive 4, which is 2. So only negatives work. Anyway, everything flips horizontally. What do you think the 9 does to it? 9 minus t is the same thing as negative t plus 9.
So it moves it left.
So it moves it left 9. If the 9 was outside here, like out here, it would go up 9. But if it's right on it, it moves it left 9. So, let's see if that works. Yeah, it does. Why does it move it left 9? Because if I try and plug in like a negative 8, no, hold on. Plug in 9, that would be, oh, I should have pushed it first. left 9 and then flip it. I think I did it in the wrong order. So I think we should move left 9 first and then flip it. So left 9 and then flip. Didn't do it.
Are you ready for your new board?
I don't know why that didn't work. Maybe outline red. No, that didn't change it. Alright, I forgot what I've done. 9. Okay. Did I copy that or not? Yes. 9 minus T. Okay, let's see what happens. If you plug in, there, I'll write it normally. If we plug in 9, yeah, okay, I got it. So we should have moved left 9 first and then flipped it back this way. So it looks more like this. So move it left 9 and then flip it to the other side. That's what happened. If I plug in negative 9, or sorry, positive 9, what do I get right here? If I put a 9 right there, what do I get?
0.
0. So 9 zeros is 40. So that'd be like right there. And if I plug in, let's say 8, what do I get? 1. 9 minus 8 is 1. So the square root of 1 is 1, right? And if I plug in, let's see, if I plug in 5, 9 minus 5 is 4. And square root of 4 is 2. So if I plug in 5, I'll get 2. So this just kind of gives you an idea, but 8, 1, 5, 5, 2, you know, whatever, something like that. Looks something like this. What I did wrong was I flipped it first and then moved it left 9, and I should have moved it left 9 and then flipped it second, I guess. Apparently that's how it has to work. But what is the domain?
Everything greater than 0.
No. Remember, domain is
less than
Everything less than 0?
Oh,
no. Remember, domain is left and right.
Oh.
So
Sorry, less than 9.
that's right.
yeah,
Less than or equal to.
yeah, less than or equal to 9.
And then range is all real numbers. Right?
Why can't I use
Everything
10 for the domain? Why does 10 not work?
Because it has to equal 0.
No, because 9 minus 10 is negative 1, and what's the square root of negative 1?
Imaginary.
Imaginary. So it doesn't work. The range, what about the range?
X is greater than or equal to 0.
Y is greater than or equal to 0.
Right.
Yeah, it goes up forever. It goes up slowly, but it does keep going up. Y is greater than or equal to 0. And what are the zeros
Negative 9.
of the function?
Negative 9.
No,
9.
9.
What?
9 is where the function equals 0 at. If you plug in 9, you get 0. That's why there's a point at 9, 0. Oh.
I think we stop at 12. That's just my personal opinion.
Okay. So on C, on almost the same thing. The 9 actually moves it left 9, and the minus flips it back to the right. But what shape does t squared? What is y equals t squared shape in? Oh wait, it's in the square root too. Here, let's just do this. We'll just plug some stuff in. What's the biggest thing we could put in for t? We'll say that. What's the biggest thing that we could put in for t? Could we put in, let's say, 10? 10 squared is 100. 9 minus 100 is negative something.
No.
Square root of negative, no. You can't have a negative under the square root, or it's imaginary, which wouldn't be graph. So, what is the biggest thing we read in? 3. Because 3 squared is 9.
You get 0.
And, yeah, 3 would work. Let's put in, nothing else works out really nicely, but 0 works out okay, I guess. If I put in, okay, let's put in 0, I guess. That's fine.
3.
You get 3. What if I put in, try to think of something that works nice. Let's just put in negative 1. What would that be?
1.
That'd be 1. 9 minus 1 is 8. So it'd be like the square root of 8, which is also 2 square root of 2. Yeah. What if I put in positive 1? What would I get? 1. 9 minus 1 is 8. Square root of 8, same thing. Alright, let's graph these, see what we got so far. 3, 0. 0, 3. Probably an easier way to do this would be on a calculator. Negative 1, 2 squared 2. How do I graph that? Well, plug it in the calculator. That 2 squared root of 2. And that would probably be the easiest way. Yeah, gosh, this one's a mess.
2.8.
2.8. Let's explain it. And then, so 1, same thing happens there, 2.8. What if I plug in negative 2, b squared 13, bigger? No. I don't think the book has the answer, unfortunately. Oh, I think I know it. If we, there's actually a limit on the small one too. If I plug in negative 3 here, that would be positive 9. Negative 3 squared is positive 9, which would come down to 0 also. So anyway, I can't go past negative 3 and I can't go past 3 because anything bigger than 3 will be bigger than 9. And anything, same thing with negative 3. If I plugged in negative 4 squared, that would be 9 minus 16. That doesn't work. So it's between these two. So it's that. Yeah, I kind of just remembered doing this last year. What is the domain anyway? What's the domain? Probably the best way to do this is just plug it in the graphing calculator. These are kind of weird, rare ones, and just kind of use that for your starting point. What's the domain?
Negative 3 is less than equal to x is less than equal to 3.
Yeah. Yes, it's everything between 3 and -3. -3 to 3. And what's the range?
And greater than 0, less than 3.
Yeah, between 0 and 3. So I'm going to call that y though. The lowest y value is 0, the highest y value is 3, everything between 0 and 3 is covered somewhere in there. And what are the zeros of the function?
Plus or minus 3.
Yeah, -3, +3, plus minus 3.
You said minus 16.
No.
Sure.
Uh,
I just helped you with the hard one. 13. Sketch the graph of each function. Use a graph to find the range and zeros of the function. X squared minus 6x plus 8. We kind of did this yesterday. The only difference is we're stating the domain and range. So how did we graph this yesterday? X squared minus 6x plus 8. What shape should it make?
Forever.
Parabola. How do we find the vertex?
We look at the thing. It's
Negative
B.
b over 2a. So negative -6 is 6 over 2 times 1. What's 3? 3 is the x coordinate of the vertex. If I find the y coordinate, plug that back in. So 9 minus 18 is -9 plus 8 is -1. 3, -1. That's vertex. How do I find the other points?
You plug stuff into it.
Plug other stuff in close to the x coordinate of the
So
vertex.
let's plug in 2.
So like 2 and 1. So if I plug in 2,
4 minus 12.
4 minus 12 is -8 plus 8, 0. 1 squared is 1 minus 6, -5 plus 8 is 3. So 2, 0, 1, 3. And then draw the mirror points. Okay, unlike yesterday, we were actually doing inequalities where we had to do like the shading and stuff. We're not doing that today. Okay, what is the domain? Yeah, all real numbers.
You don't need domain, do you?
Oh, I thought it asked for it. What did it say?
I think it's just range and zeros.
Sketch the graph, use the graph to find.
Yeah, it's just range
Okay.
and zeros.
Probably because the domain is
Always
all real numbers on all 4 of those, so they didn't ask. Okay, what is the range?
Everything greater than -1.
Yes. -1 and up. So range equals y is greater than or equals to -1. And what are the zeros of the function?
2 and 4.
2 and 4. How could we have found the zeros of the function without graphing?
Plug in 0.
No.
If you plug in 0
No.
or 2 and 4.
It's where what x value makes the function equal to 0. You have to solve this equation by factoring. By factoring or using the quadratic formula. Okay. 4x is 4, x is 2. That makes it equal to 0. 2, 4. The zero is the function, or you can use a quadratic formula. Alright, next, last one. Number 15, 2 minus 2 cubed. Alright, it's been a long time since we did this one. Well, normally what does a cubic function look like?
That's the one where it's the end.
Yeah. However, 2 is what we call a triple root. Now we did some double roots yesterday, but not triple roots. You guys remember what happened on a triple root a long time ago?
Got the weird squiggle at
Yeah.
It bounces or something.
It doesn't bounce. Double roots bounce. Triple roots
half.
flatten out like it's gonna bounce, and then they keep going. So it looks something like that. So it doesn't even look like an N at that point. It's, yeah, normally it does look like an N. I forgot what we're doing. Range? Yeah, range. What's the range?
Is that all numbers?
All real numbers. It's confusing. Why equals all real numbers?
And then X is 2.
And x equals 2, yeah. Use the zeros as a function. Short answer. Okay, on number 14. What shape would that make? Parabola. It's an x squared problem. It's a parabola. That is not in standard form, so I would not use negative b over 2a. I would use the minus 3 moves the parabola right 3, and the positive 4 moves the parabola up 4. So the vertex is at 3, 4. Number 14. The parabola will be going down from there though, because there's a negative in front of the x. Alright. How about, I'll just say, let's do 1 through 15, then we'll talk about 16 on Monday.
What?
Just do to 14, and then we'll do 16 on Monday. Just ruin Brady's life.